Here's my attempt to explain this summary with one single function. So this should give you like the nuts and bolts about how to do this. We're going to do it with a polynomial function. It only really gets difficult when you have a more complicated function. So here we go. We'll start with critical numbers. So the function we're going to look at is this polynomial function. To find the critical numbers, first you determine the derivative. So the derivative is negative 3x squared plus 6x. Then you set the derivative equal to 0 and solve. So what I did here was I'm going to set this derivative equal to 0. So, and solve it. And the easiest way to solve this is to factor. And then the first factor would have a solution x equals 0. The second factor would have a solution x equals 2. And these values are the critical numbers. And that's it. That's how you find critical numbers. Then the next section is relative extrema. Now, relative extrema can only occur at critical numbers. So this really hinges on the fact that you have to be able to find critical numbers, which we just did. Now, a relative minimum occurs when the derivative changes from negative to positive, and maximum vice versa. So to find the relative extrema, we're going to set up a chart with intervals divided by the critical numbers. So here we go. Our critical numbers were 0 and 2. So when I set up the chart, it's going to look like this. Oops. All right, 0 and 2. That separates the intervals to be negative infinity to 0, 0 to 2, and 2 to infinity. So the next step in doing this is you have to pick a test number in each interval and determine the sign of the derivative. So we're on this part. So I'm going to do that right now. I'm going to test. In this interval, we're going to test the point -1. Now, we're testing the derivative, so it's going to be f prime of -1. This middle interval, we're going to test 1 is in that interval, so we'll do f prime of 1. And finally, the last interval, we'll do f prime of 3, because that's definitely in that interval. So we're looking at the first derivative. So I'm going to remind myself what the first derivative was. It's right here. It's easiest to deal with a factored version because all we're really worried about is if the derivative is positive or negative. So I'm going to look at this factored version right here. If you plug -1, so at this interval right here, into this factored version, you will get -3 times a -1 here, which is a positive. And then the second factor, you'll get -1 minus 2, which is -3, which is negative. So it's a positive times a negative, which is negative. Now it's time to go to the next interval. The next interval is right here, f prime of 1. So if you plug 1 into the first derivative right here, you'll get -3, which is a negative, times 1 minus 2, which is a negative, which is positive. Negative times a negative is a positive. Finally, we're going to go the last interval, we're going to use 3, plug it into the derivative. 3 times a -3 is negative, and 3 minus 2 is positive. we get a negative times a positive, which is negative. So, according to our instructions here, if the derivative goes from negative to positive, then it's a minimum. If the derivative goes from positive to negative, it's a maximum. So we went from negative to positive here, negative to positive. That's the minimum. And we went from positive to negative here. That's the maximum. So we have a minimum at 0, comma, and a maximum at 0, or I'm sorry, at 2, comma. So you're using these critical, you're using these critical, try that again, these two critical numbers. And finally, you plug in the x values to the original function to find out the actual points. So we're going to have to, when we found these mins and maxes, we're going to have to look back at the original function, which was this, and plug these critical numbers for the min and max into that function to see what the y value is. So if you plug 0 into this function, you'll obviously get a negative 2. If you plug in 2, you'll get a negative 8 plus 3 times 4, which is 12, minus 2. That will be 2. And there you go. I'm going to stop here and make a new video for the rest of it so it doesn't get too long and boring. I'm sure it's not boring. I meant so it doesn't get too long. So thanks for watching, and we'll do the next part in a bit.